Right, so I'm going to go over some of the homework problems from last night, particularly 36, 37, and 41. For 36, you have to determine whether the triangles are congruent first. So I think I saw from some of your homework that you were using the triangle angle sum theorem, subtracting from 180, 39, and 25. So that would equal to be, I believe, 116 degrees. Angle A is 116 degrees, and then this one was 25 degrees. And since they have 16 degrees in common, they both have 116 degrees. Oh gosh. Sorry. Okay, they both have 116 degrees, so angle A is congruent to angle E. And they also both have 14 as the side length. And then lastly, the little angle here, this is angle 25 degrees, which would be congruent to angle B, also 25 degrees. So by angle side angle, the two triangles are congruent. The red angles, side 14, and the blue angle, so you should have created a flow chart. Now for the flow chart, there's no tick mark. So you're gonna have to state all the given measurements for this one. So the first part that I stated in my flow chart are angle A measure, which is 116 degrees, and the measure of angle E, which is also 116. I have to state those because that's the given information. And by definition of congruence, they're both congruent. So do the same thing for the other blue angles, as well as the segment AB and EF. So here's what I have. I made a mistake, sorry, in the beginning. The 116 degrees for angle A was not given. It's actually the angle we found using triangle angle sum theorem. So sorry about that. I totally forgot that we had to find the angle A. Same thing with angle F. We use a triangle angle sum theorem to find that the measure of angle F is also 25 degrees. So we got two triangle angle sum theorem reasoning for the bubbles. And then now that we have the three information that allows us to prove that the triangles are congruent, all of those last three bubbles will lead to the conclusion that the triangle ABC is congruent to triangle DEF by angle side angle. That's what that was. And then for the last part, you had to find the length of the segment DF. For part B, find DF. Well, if the two triangles are congruent, everything has to be the same, right? So then if they're both the same, and we know that this side, AB, corresponds to EF, can you see where the side BC corresponds to in the second triangle? Yeah. BC corresponds to FD. Therefore, they both have the same length because they are congruent triangles, and congruent triangles must have the same side. So DF is going to be 20. And again, because both triangles are congruent, that they have the same side lengths. Okay, because the triangles are congruent, they all must have the same size. So you just have to find the corresponding part. And then number 37, I had a lot of question about this one. It says, looking at the picture, the smaller triangle, which is this one right here, this is a smaller triangle, is similar to the large triangle, So what you can do is actually take out those two triangles and create into two separate ones. So I'm going to start with the small one, side x8, and then draw the large one, 8, 10. Now it doesn't tell me whether the small one turned into a big one, whether it's an enlargement or reduction. It doesn't tell us. All we know is that they are similar. So what we have to do is write a proportion, which what it means is you're just writing ratios, two ratios. So this is a method that Ms. Park talked about when using the scale factor. Find the ratio of the two triangles and put them all together. For example, if I say the ratio of the large triangle to the small triangle, and you can choose, it's got to be 10/8, right? The bottom part of the large over the small is 10/8. So then what's the other ratio? You can do 8/x. If you don't want to do it this way, you could flip it over and do the ratio of small triangle over the large triangle, which is now 8/10, small triangle at the top. So 8/10 equals to x/8. It doesn't matter, but that's what a proportion is. And how do we solve it? Cross multiply. 8 times 8 is equal to 10x, so that's 64. Divide both sides by 10, x is 64/10, which simplifies to 32/5. I'll keep that as a fraction. That's the answer. That's all you had to do. And if you do the same thing with this one, you're going to get the same answer. Doesn't matter which way you start the ratio, which way you write the ratios, all right? So no scale factor in this one, you just write ratio of the two sides. The last one, in this one, you have two similar triangles. You have to solve for x. So this problem is actually very similar to the one we just did, this one. See how you put two figures and you wrote the proportion? We're setting the two ratios equal to each other. You're basically doing the same thing. And this is always true for similar figures, right? Similar triangles. You also have similar triangles. Now, the hardest part, I think, is writing the ratios. So we got two triangles, one on the right and one on the left. And you have to be careful about reading the diagram and find the corresponding parts. Meaning, this side of the triangle on the right, it corresponds to this part of the triangle. Hopefully you can see that. This side is between the angles with two tick marks. So in the other triangle, the side with two tick marks in between would be the side 24. So then the ratio of the side length on the right triangle, which is x plus 2, over the ratio of the corresponding part of that triangle, it's 24. That's one ratio. So you can do the same thing for the other side. Now this is a side x of the triangle on the right. So x over the other corresponding part in the second similar triangle, 20. Make those two ratios equal to each other. That's what a proportion is. And you can solve this by using cross multiplication. 20 times x plus 2 is 24 times x. 20x plus 40 is 24x. Now I think you can solve them yourself, subtracting 20x both sides. 40 is equal to 4x. And x is equal to 10. You can check it yourself, actually, and figure out what the scale factor is. This side, 10 plus 2, this is actually 12. And then this one is 10. So what do you notice? Right? You could say from left triangle to the right triangle, the scale factor, it looks like it's going to be a half from left to right. Or if you go from right to left, it's being doubled, right? So x is equal to 10. Okay.